We have 0.ABCD plus 0.EFGH, where all of these are digits equal to 1, and then each letter stands for a digit from 1 to 8, but in part A, they have to be different. We have to prove there's no solutions. So I'm going to set this sum up. Right, brilliant. Now they're all non-zero, so we must have that D plus H is equal to 10. That's the only option here. So what I would do is we'd get the 0 and then we'd carry the 1. And then C plus G plus 1 is going to equal 10. So actually C plus G is going to equal 9. We'll still get 1 to carry over, which we'll then put here. And the process will continue. B plus F will also equal 9. And A plus E will equal 9. Brilliant. So I've got some relationships between these things. Okay, so let's have a look where you're trying to use the numbers from 1 to 8. And they have to be different. So I wrote down the pairs of numbers that add to 9, 1 and 8, 2 and 7, 3 and 6, and 4 and 5. You obviously can swap them around, but those are the pairs. And then pairs that add to 10 are going to be, or there's no 1 and 9, so it'd be 2 and 8, 3 and 7, and 4 and 6. Okay, now here's the thing. And okay, I'm explaining it, so it's like, yeah, this is what we do, but you've got to kind of look at it for a little while. And if you pick any pair that adds to 10 rather, like 2 and 8, then when you pick 2 and 8, you can no longer pick either of these pairs here. So there's no way that I can get a pair that adds to 10 and then three pairs that add to 9 if I pick 2 and 8. And the same goes for all the other pairs, in fact. 3 and 7 will rule out these two. 4 and 6 will rule out these bottom two. So that is the main part of the argument, really. I feel that's reasonably comprehensive. Maybe just a little example. Okay, that's pretty decent, I think. Maybe a little bit more is expected in this kind of Olympiad to justify it, but this is at least a good sketch of an argument. Actually, I take that back. I looked at the solutions and they did something very similar. So I think this is a solid effort. Right, in B, we're said that we can do the same thing again, but now we can repeat digits, and we're asked how many solutions there are. We may give our answer as a product of prime numbers if we want to. So that probably means it's going to be quite large. Okay, so from before we have this. Okay, I need to write that whole thing down. I'm just bringing it down so it's easy to see. Okay, and I got these. Now, because I can repeat digits, now I also have 5 and 5. That's really important. And actually, when I did this question, I think I missed that out. I wasn't careful enough. We can also swap the digits around. So I'm actually going to write these out. 8, 1, 7, 2, 6, 3, and 5, 4 are our options. And here, okay, if I swap 5, 5 around, it will look the same, but I've got 8, 2, 7, 3, and 6, 4. So there are 1, 2, 3, 4, 5, 6, 7, 8 ways that I can add my numbers to 9, and 1, 2, 3, 4, 5, 6, 7 ways that I can add them to 10. So let's take a look at this. If I'm picking A and E to add to 9, then there's going to be 8 options. And then for these 8 options, there's going to be 8 options for BF. And then 8 options for CG. This is using the product rule of counting. And then finally for DH, actually, there's 7 options. Now, the only thing about this is that we've double counted, because if you swap them all around, like if you get your answers, trying to work out like a possible solution actually. So 0.8 and then E would be 1. Let's let B equal 7. And then we'll get 2 here. Let's go with 5 and 4. And then 5 and 5. Okay, that would give us an answer of 1. Then at the moment, I've also counted the solution 0.1245 plus 0.8755 as something different. And actually, if we look at it, it says how many solutions are there? Well, that's not going to count as a separate solution. So what I'm getting at is that we've got our 8 times 8 times 8 times 7. I hope this makes sense. 8 choices for this pair, times 8 choices for this pair, times 8 choices for this pair, times 7 choices for this pair. Okay, we've got this 5, 5 in there as well. But we've double counted because these two, although they've been counted separately in my solution, they actually are the same solution. So it's going to be 8 times 8 times 8 times 7 divided by 2. We're asked, we can write it as a product of prime factors, so I can write it as 2 to the power 3 times 2 to the power 3 times 2 to the power 3 times 7 divided by 2. So that's going to give me 2 to the 9 divided by 2, 2 to the 8. So finally, the answer is going to be 2 to the power of 8 times 7. Nice one.